Okay, so a couple people wanted a video explaining problem 1A and 1B from Precalc review number 1. So for 1A, if you think about that right there, we want to reach back into our minds from Precalc, and actually you can just look in your formula packet for the double angle identity. So essentially we know that 2 times the sine of x times the cosine of x is equal to sine of 2x. That is in your formula packet, so you don't have to have that memorized. In the packet of resources that I had you pick up at Southridge, I think one of the last ones was just a small packet of just formulas. You are allowed to use those anytime you want on the IB exam as well. So it's good to get used to what's in there so you don't have to memorize stuff. Okay, so essentially, if we look back at the original problem here, that 6 in front can be thought of as a 3 times 2. And then I have basically this part of the problem is the same as that part of the problem, so I can substitute that in. So then that would be equal to 3 times the sine of 2x. That's the yellow part right there, right? And then we can just tell what A and B are from right there. So A would be 3 and B would be 2. Okay, so for the next one, this expression right here, it's built off, it says hence or otherwise, which means it's kind of IB language for hence means use your previous answer to keep moving forward for part B. And then the or otherwise part means do it any other way you want. So they're actually giving you a hint that you can use part A. So since we already did the work for 6 sine x cosine x, and we can write that as 3 sine 2x, and then write that equals to 3/2. Now I could divide both sides by 3, so we have the sine of 2x equals 1/2. And then we have to try to figure out the sine of what angle is 1/2. So I'm actually going to think in my mind just temporarily about the sine of theta instead of 2x. So where theta is equal to 2x, just to think about a simpler problem. So this is the problem I want to try to work out first. But notice that we are going to have to try to think about the answer between the interval of pi over 4 and pi over 2. So you know how there can be there can be an infinite number of answers for trig equations, but they're restricting the domain here. Okay, so I'm going to make a little triangle. You know, if you're really comfortable with the unit circle, you can use that method. But the way that you made the unit circle initially last year, or maybe even in AGS 3, was to think about special triangles. So this comes from a special triangle that's half of an isosceles triangle. Like if I were to continue this out, drawing skills aren't all that great, and this would also be 1, this would be 2. So this is an isosceles or equilateral triangle. And if you use the Pythagorean theorem, you get the square root of 3 for the hypotenuse. It's not going to be relevant to this problem because basically I want this angle for sine to give me opposite over hypotenuse, which is what sine is defined as. And so that angle right there, theta, is going to be pi over 2, or sorry, pi over 6. Okay, so it's one of those special right angles. That's because an equilateral triangle okay, sorry, I got interrupted there. So basically, we can try our answer pi over 6. If we use pi over 6 is equal to 2x, because remember I'm using that equation right there to translate between what theta was and what my answer really needs to be for x. So that means that x would be pi over 12, but that is not inside of this range. It is smaller than pi over 4, so that is not going to be one of our answers. So we need to look at the next possible answer. I'm going to draw a little quick sketch. This is something that I like kind of think about in my mind when I do these problems, but you're always welcome to draw. So here's a really rough sine curve for one period, one cycle. That would be pi. This would be 2 pi. So if I'm looking for where sine is equal to 1/2, then that would be somewhere in here, right? So this value, there's also another value right there within one period. This first value is our pi over 6 that we found. And so the next one, we can do pi minus pi over 6 to get this one, to get this answer right here. It's basically going all the way to pi, and then this is symmetrical, so we can subtract pi over 6 because it's the same way in from that side as it is from that side. So if you subtract that, you get 5 pi over 6. And then we can try that angle. So if we did 5 pi over 6 and say it's equal to our 2x value, because that's theta, then I would divide by 2. I would divide by 2 and I would get that x is equal to 5 pi over 12. And 5 pi over 12, 6 pi over 12 would be a half of a pi. Half of pi, and then this is less than that. So it does fit within that range, so that's all good. So this is our answer. Hey, there are other ways to do this, of course. I'm just trying to show you the kinds of things that I'm thinking about in my head as I do the problem.